3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Hello everyone, thank you so much for being here and welcome to this, the inaugural episode of the Laboratory News podcast. Yeah, thanks for that, Mum. So who are we and what the hell are we doing with this podcast? Good question. So we are Laboratory News magazine and hopefully some of you know us. We've been around for donkey's years, 40 years in fact. Essentially, we try and drive and provoke dialogue around science, how it shapes our understanding, the challenges we face as we conduct that science, and how we might improve the way we go about it. And these are all themes that we'll continue to look at in this podcast. I'll be your host. My name is Phil Prime, and along with the editor of the magazine and the brilliant writers and contributors to the publication, I'll be holding your hand as we approach the very vanguard of science. Essentially, I'll be sliding the words gently into your ears instead of you using your own eyes to read them. Oh, I'm sorry. I'm just getting used to all this. That was absolutely gross, wasn't it? Anyway, moving on. So, my plan is to bring you at least one episode a week. Some of them will be magazine-y type episodes like this one where we talk about lots of different things. Some of them will be long-form interviews, or some of them might be special one-offs. Often we'll be doing so in close conjunction with the printed version of Laboratory News or the website, where we'll give a slightly deeper look into some of the issues raised. And just like the magazine, this is your podcast. We want you involved as much as possible. This is by scientists for scientists. So let us know what you want to talk about, what issues you want us to get into, and we'll do our level best to make that happen. Right, that's quite enough preamble from me, I think. So first up then, we have a look at why it was that a good old-fashioned bit of scientific serendipity led to this. As you may have guessed, that is an underwater recording of a whale. But not any whale. This is a recording of one of the most shy and skittish animals on the planet. These were the sounds of a narwhal, an animal more famous for its look than its sound. The recordings were made from a glacier in Greenland last summer, and I caught up with the man behind the work, Evgeny Podolskiy, to find out why it was that an Inuit hunt was so key to all this. Now, Evgeny is actually an assistant professor of geophysics at Hokkaido University in Japan. So what on earth was he doing in Greenland recording narwhals?
Well, I ended up in this area since 2015, and we were most interested to study glaciers, which are changing there at very impressive rates and losing thickness for about 4 meters every single year. And when we just work in the area, which is a home for Inuit people who are hunting whales, we see whales in different situations, like killed as a source of meat by locals, or from helicopters. And I just realized that actually we are working in one of the key submarine grounds for narwhals in Greenland. There are probably 8,000 or more narwhals coming every summer. The main purpose of mine is to bring long-term observations for starting answering questions about the changes, trends, and seasonality of their appearance and behavior. And to answer more complicated things, we need to start first some reconnaissance work in the region. So this was the idea, to document the soundscape, which is a home for this unique animal.
The recordings are undeniably beautiful, and I think most of us would recognise the sounds as being organic. biological in nature. But did the team realise that at the time?
When we are going to the sea, we don't know what will be recorded because not always we can see, but our purpose of doing this supervised observations from board, so we kind of try to note what's going on around us. So we know that, this is a whale coming over there, this is iceberg rotating and making this crazy thunder-like rumbling. And as we go there, we can have many different animals, because actually these Arctic fjords, they have many different marine mammals. And so one is narwhal, another one, their close relative, the closest relative, which is beluga. Also, we have seals, different types of seals, and these guys, they are making all kind of very spooky, weird sounds, and usually in spring. And then finally, I was surprised to find out that even a fish like Arctic cod is making sounds which sound like grunting, like a pig. It's unbelievable. By looking at the signals properties, we can distinguish different animals with analysis.
So clearly there's some really accurate and interesting zoological data here, but it's all come from instruments and techniques rooted in geophysics. So do we sense a change of discipline here for Evgeny?
Well, not at all, actually. You see, because for me, I'm certainly not a biologist, and I'm not terribly kind of upset about that, because what I do is signal processing. And when you deal with signals, we are using the same tools for analyzing earthquakes, icequakes, hydroacoustic weird noises, and noise analysis is kind of my bread and butter.
And what noises they can be. Just listen to this. This is the sound of bubbles escaping from a melting glacier.
When it comes to these records, there is a lot of things to do for signal analysis. So that's how I feel about it. And I feel pretty excited and comfortable because, I thought that I've been working with pretty wild signals so far because we work with glaciers, and compared to earthquakes, they are producing incredible diversity of different seismic acoustic events. Very different from earthquakes and volcanoes. And I thought I've seen enough, but then I saw these whales. Oh God, they are so much more sophisticated. It's impressive and interesting.
Impressive it most certainly is, but do we know what's actually going on? What are the narwhals actually trying to communicate? Presumably, Evgeny was completely overrun with narwhal enthusiasts trying to help him out.
Oh, not at all, actually, because, I was doing analysis of signals by myself. I don't think there are many experts in the world who can say immediately which signal is what, but we can learn from literature what to expect and how to distinguish narwhal from beluga, narwhal from seals. And so there are places to look for information, certainly. But at the same time, still there is a lot of disagreement and different interpretations of behavioral context of the sounds we record.
So there's clearly a real need for more experimentation here. But is simply dipping a microphone, however sensitive, into the sea really the best way to go about this?
When you think that we are dealing with animal living in this remote, sea ice covered, dark for half a year environment, how do you expect to have many observations of their behavior or just presence or migration patterns? So the information about them is pretty limited, and sounds may help us to answer some questions about these animals. What we also could do is to attach microphones to the animal. This is the best to get the highest quality records with fully comprehended behavior recorded by the senses, like are they diving, are they at the surface, whatever. And but this is extremely challenging, and it's such a stressful event for an animal because you have to catch a whale, and then you will have 1, 2, 3 whales who will lose these sensors in 4 days. So it's difficult. So that's why we hope that passive acoustic monitoring in the area can help to study these animals, and this is towards what I'm kind of trying to move with this paper.
Now, in an expedition jam-packed with interesting facets, perhaps the most interesting is the fact that Evgeny enlisted the help of some local Inuit hunters to find the narwhals.
The way they are legally allowed to hunt a whale is that they have to do it in traditional way. So Inuit hunters should use traditional tools to catch a narwhal. And the way they do it is with kayak and harpoon it.
And of course, there's a very good reason why this ancient tradition has proved so useful. Modern boat engines scare off the elusive narwhals, but that's not all that modern research can get from this ancient way of life.
For scientists who have no clue about anything and even not able to spot a whale, because this is an amazing thing, because when you are in the village or in the ocean, when locals say to you, look, a narwhal or narwhals, and all foreigners or non-locals, they're just like, where? Like, and they're like, there, look, are you blind? It's amazing how sharp their eye is in this environment to spot animals. And this is what we need, because it helps us to get really, really close to this shy and skittish animal, which is very unusual to see from motorized boats.
But this does rather beg the question, how do you go about securing the services of an Inuit hunter?
Well, we are working in this area for 5 years already. For me, and for more years for my colleagues who have contacts there, and we always engaged and involved local pilots for boats to do oceanographic observations in glacial fjords. And this is extremely helpful because, well, on one hand, they are very skillful in navigating icy waters. And on another hand, we don't have any research vessel, and it's too troublesome for our relatively small scale operations. So we started to work with locals. We help them with fuel and expenses for running boats, and it's mutually beneficial for them and us. But yeah, objectives are very different.
And that's what's so stark here, isn't it? You have a research expedition and a hunting expedition, both trying to track narwhals. So I wonder, what do the hunters think of the researchers?
Well, of course, they're curious to see, to hear this, but in general, they're interested really in catching a whale. So their objective, to be honest, is very different from our objective, and especially, well, for a foreigner who is not from Norway or Japan, killing a whale is not such an impressive thing to do. So we are not interested in that so much. So far, it's really a collaboration. It's really good to trust just them where we go and for how long, and if we wait or not. It's a very fruitful so far effort.
So there you have it, Evgeny Podolskiy, the very model of a modern interdisciplinary researcher there, from geophysics to marine biology, care of some Inuit hunters. So there you have it, gang, the very first Laboratory News podcast. Thank you so much for listening this far. But before I let you go, here's just a taster of what's coming up over the next few episodes.
Using all the techniques that we use to find the antibodies against every other virus we know, they didn't find them against coronavirus, which tells you something about the immune response.
It turns out that a viral pandemic is worth 1,000 PR campaigns because everyone knows who a virologist is, why they're important.
The thing from my point of view, because I'm a biomedical scientist, so the diagnostic side of it, this has now become, unfortunately, this has now become a bit of a political football.
Bear in mind, I'm a lowly biologist, I'm not a physicist. So take us through what a Bose-Einstein condensate is.
These are very sensitive objects, so it's very difficult to make them. But on the other hand, once we make them, you can use this property and use them to sense different kinds of fields.
And I didn't realize that it's basically impossible to stop a turtle physically. It just rolls you over. It's literally a very heavy, hard-shelled bulldozer.
So I do hope that has whetted your appetite just a little bit. Until the next episode then, thanks so much for listening and I'll speak to you then. Stay safe and stay sane.